To what's on chapter 14. You may recall that I had a specimen like that in chapter 14. The bottom two end pin faces were clamped, and the top two faces were subjected to an upward direction. Now, I'm going to be repeating this problem, except that the bottom two ends are not clamped, but also being pushed down exactly the same way by the same amount. In a downward direction. So now I have three planes of symmetry. Two of them are exactly the same that what was done. So let me activate those. Activate. So update. So this is what we had in chapter 14, video segment 2. Now I have a third plane, which is the XY plane. So I'm going to split it again with the XY plane, all of them. No, actually cancel that for a second. Cancel that. Okay, we've got to be careful here because when I cut this, let's think about it carefully. When I cut this thing, I want the block to be cut. Okay, there we are, and I keep the top face. This bottom pin, is when I cut it, actually it doesn't even come into the picture. So you know what, the thing is that we need only one pin. The bottom one is not needed, okay, because when you imagine when you cut the XY plane, this bottom one is not needed. So let me try all of them. Okay, good, fine. All right, the bottom one, if we cut it, then it's going to be gone. Actually, I don't really need it. Okay, so save everything in that folder. We now go to generative structure analysis, just like before. And if you look at the mesh and the block, the other pin is not even participating. You can see that. You can actually make the elements around the hole smaller, and this was done in video segment 1. It's your responsibility to go and watch it if you want to know how. I'm not going to do that. So okay, deactivate this mesh. Let us actually apply our symmetry restraint. So surface slider, think about it, this face, the quarter or half of the pin over here, and then this top face, face of the pin, face of the block, and the bottom, right there. Okay, and then I want to push this thing up by some amount. Okay, push this thing up by some amount. So first I make it 0 in that direction, upward direction, right there, and then I can change it. And force displacement, right there, 0.01 inch. Remember, the amount of the displacement does not change with how many cuts you make. That still goes up by the same amount. Okay, very good. And now create our connection. So a connection between this face and for the second component, hide the surface of hide the pin and select the surface of the hole right there. And this connection, we're going to make it contact. Where's my contact? Right there. There's my contact. And this connection is either this white dot or from the tree. There's only one connection created, which is right here. You can see that. Do not fool around with these clearance, friction, no sliding, because I haven't taught you how. I haven't, and I don't want you to do it on the final. All right, that's pretty much it. So let's bring this thing in the front. We don't have to, but makes us feel better. Okay, save everything and run. File, save management, save as. In that same folder is the new one that I created. Not there, This is the old one. So we have to go and find the folder that we want, which was called almost chapter 14, right there. These three folders are independently working of each other. You have not overwritten any analysis file. You have the analysis in the first folder, analysis for no symmetry. In the second folder, analysis with two planes of symmetry. And the third folder, analysis with a quarter. These are independent folders, independent runs. Okay, so did I run it? Let's do that. Hopefully I didn't forget anything. But this is just a warning message. Don't worry about it. We've talked about it in the past. And it is done. So there's the deformation. Look at the side view. Okay. Right there. Animated. We can see there's a gap that develops. If you made this thing fasten, if this connection fastened, this gap will not develop as if this entire object was machined or casted like that without the pin being part of the block, really. You can also make it rigid, but it's wrong because rigid means that when this thing deforms, things do not change shape and size. So do not do that. These type of problems must be contact. And there's the von Mises stress. I don't have any confidence in these numbers. These are probably all wrong because meaningless because there is no good mesh. This is not a good mesh around in the block. That's for sure. And change the rendering here. There we are. And watch the previous video for finding the amount of force needed to lift this thing up by that much. Okay? To cause the deformation of the original structure by the indicated amount. And remember, for the answer in the book, in the test, you have to multiply it sometimes by a factor of 2 or 4 or 8 or maybe not, depending on what you have done. You cannot memorize it. Just have to use your common sense. Okay, that's pretty much it. You know what? Just to show you why I cannot trust these numbers. Okay, let me go and rerun this problem with parabolic one. This was 115,000 psi. Okay, let me make it parabolic and run it. 115,000 psi maximum stress. For I don't know where it was, but for now let's just pretend that it was a, you know, the place that we wanted it. Okay, look at the stress now. $119,000. The only thing that's bothering me is that this stress is in the probably the pin. I'm not sure. Anyway, I don't have any confidence in these numbers because we did it on the fly without a proper mesh conversion study, and one should be very